Hi everybody, this is Mr. Short. Today we're going to talk about isotopes and the calculation of average atomic mass. Now I'm starting out with this picture of the three hydrogen isotopes, which are H1, H2, and H3. This is a picture that you have from your notes before. And remember, the definition for isotopes is that isotopes, they've got a different nucleus, but they're still the same element. Therefore, isotopes of the same element, they have the same number of protons, but different numbers of neutrons. We can see how that applies to this picture by noticing that each of these hydrogen isotopes has one of these white protons inside the nucleus, but they have 0, 1, and 2 neutrons inside the nucleus. So same number of protons, but different numbers of neutrons. So we might ask the question, well, given that the average atomic mass for all hydrogen isotopes is 1.00794. How do we get from this information right here to this information, which is average atomic mass right here? We're going to take a look at one practice problem. Now, this isn't a sheet that you guys have. This is a sheet that I've used in previous years, and we're just going to adapt it so that we can practice this calculation. So if you take a look down here on the bottom, this is the proper way to do the calculation for average atomic mass. You can see it tells us that there's a certain element that exists as 4 different isotopes. So each of these isotopes would have the same number of protons, but different numbers of neutrons, and for that reason they would each have a different mass. And it tells us that about 4.35% of all isotopes have this particular mass, about 83% have this particular mass, about 9.5% have this particular mass, and 2.36% have this particular mass. And it asks us, what's the average mass for this element? Now this down here, this is the proper way to do this calculation. So when you're calculating average atomic mass, this is a 3-step process. Step number 1, you're going to convert the given percentage to a decimal, and the way that you do that is by taking the given percentage and just dividing it by 100. That conversion right there is something you guys have been doing since probably middle school. So for example, instead of writing down 4.35%, we have to divide that by 100, and you get this number that's right here. Okay? You do that for all the given percentages. You've got to really keep track of your information in this. And these are all percentages that have been converted to decimals by dividing by 100. So again, you convert the percent to a decimal by dividing by 100. Then you multiply the decimal times the mass for each isotope. So for example, the one that has 4.35% abundance, it has a given mass of 49.9461. So we take the mass, multiply it by the percent expressed as a decimal. Then we do that for all isotopes of that particular element. And then we add up the product of those calculations, and it adds up to 59.9958. Now you have to be a little bit flexible when you do this calculation because different periodic tables will have slightly different masses. Alright, so take a look. This is our calculation right here, and we might ask the question, well, what element are we talking about? We want to find the element whose mass, average mass, is closest to 51.9958. And if you take a look right here, chromium has a mass that's very, very close to that, 51.9961. So it's only 0.0003 atomic mass units off, which is really close. And it just represents slightly different information on slightly different periodic tables. All right, so again, when you're doing these calculations, you convert percent to decimal, multiply decimal times mass, add those up. And the nice thing about these calculations is that you've essentially got a cheat sheet for it. It needs to line up really closely with something on this periodic table right here. Okay, I'm also going to zoom out a little bit, and you guys can, if you would like, take a look at the other calculations that are on this sheet, some problems that students made when they were doing these calculations. All right, so I'll leave that up there and you guys can take a look at that if you would like, but this is the one that shows the correct way to do it. All right, thanks a lot, guys. Good luck with your average atomic mass calculations.